Please click on subscribe button and click on bell icon for more interesting updates on civil engineering concepts. In this video lecture, I will explain you minimum percentage of the steel and maximum percentage of the steel that is required for designing of any kind of the building which is related to the beam sections and column sections as well as slab sections and foundation section. Okay, so basically if you want to design any one of the structure, whether it is a ground story building or G+1 building or G+2 building, basically the minimum percentage of the steel and maximum percentage of the steel we have to consider. Okay, why? Because if you exceed that respected percentage of the steel behind that respected value, basically the value of your respected cost of the project is increases. So to overcome this respected problem, basically we need to consider the minimum percentage and maximum percentage. So after calculating the reinforcement values as per your respected StatPro software or ETAP software or manual calculations, just we have to check that whether that respected percentage of the steel is within the limits or not. Okay, basically the percentage of the steel is depends upon the two factors. Okay, under that first one is loading condition section and another one is grade of the concrete. Okay, so let us consider, just I am interested to construct a building which is related to the G+2 structural model. So for construction of G+2 structural model, we will consider the column sizes, let us take 12 inches cross 12 inches and beam sizes 12 inches cross 9 inches and slab thickness will be of 125 mm and foundation dimensions as per the standards. Okay, so before construction of G+2 building model, we need to calculate the reinforcement values for the steel section. Okay, so we need to calculate the what is the amount of the percentage of the steel that is exist for that respected members. So before calculating the amount of the steel for that respected members, initially we need to fix the percentage that is related to the maximum and minimum percentage reinforcement section. Okay, so for that respected building of G+2 structure, basically the reinforcement values will be depends upon the two factors which is related to the loading condition system as well as your respected grade of the concrete. So these are the two factors which is considered for minimum and maximum percentage of the steel in concrete member, which is related to the beam sections, column sections, slab section and foundation section. Okay, so firstly loading condition. Basically the loading condition will be depends upon your respected building considerations, whether it is comes under your low rise structure building model or medium rise structure building model or high rise structure building model. So let us consider we are taken that respected building of G+2 building model, so that is comes under your low rise structure building model. So for that respected building section, we will consider the load cases which is related to the gravity directional condition system as well as lateral condition system. Okay, so which is comes under your dead loading condition, live loading condition as well as your seismic loading and wind loading condition. Okay, so if the loading condition on that respected building of G+2 is higher, basically to resist that respected loading condition, we need to increase the reinforcement value. Okay, so this is the first factor that will be effect on your maximum and minimum percentage of steel. Okay, so next one is grade of the concrete. So for this respected G+2 building model structure, it is sufficient to consider M25 grade concrete. Okay, so if you increase that respected grade behind the M25 grade structure, basically the weight of the structure is also increases. To resist that respected amount of the intensity which is related to the loading condition, just we have to consider the grade of the concrete. So if you increase the grade of the concrete structure, basically the value of your respected load will be increases. Due to that reason, we need to increase the percentage of the steel. So these two factors are the main important things which is affected on your respected concrete grade. Okay, so now I will explain you what is the minimum percentage of the steel that will be considered for beam design section and column design section, slab design section as well as foundation section. So if you want to design any one of the building which is related to the beams, we will consider the minimum percentage of the steel is 1% and maximum percentage of the steel is 2%. Okay, so this respected percentage of the steel will be considered as per the IS codal provision standards. So this respected value is showing that respected 1% to 2% value is considered as per the standards which is provided by the Indian standard system. Okay, so next one is column section. If you want to construct any one of the building, whether it is G+2 or G+3 or some other structure, basically we will consider the minimum percentage of the steel is 1% and maximum percentage of the steel is 6%. Okay, so we will consider this respected 1% as well as your 6% for the respected column section. And next one is slab section. So let us consider it will be consisting of your respected dimensions of percentage of 0.7% is the minimum and 1% is the maximum. Okay, so next one is foundation design. So if you want to construct any one of the building which is of related to your medium or low rise or high rise building, we will consider the percentage of the steel minimum is 0.7% and 0.8% is the maximum. So please remember this respected values. This is important part of your respected projects, any one of the project. So basically if you design any one of the structure in StatPro macro software, if you double click on any one of the member which is of beam or column, it is showing that respected percentage. It is required for this respected member, it is required so and so percentage of the steel for this member. Okay, so that respected member we need to check that whether it is having this limits or not. Okay, for beam section it is consisting of 1% minimum, 2% is the maximum. For column section 1% is the minimum and 6% is the maximum. For the slab section 0.7% is the minimum and 1% is the maximum. Let us consider foundation section, which is comes under 0.7% is the minimum and 0.8% is the maximum value. So these are the 4 factors. Now I will explain you one simple example so that you can easily understand how to calculate the steel that is required for the member. Okay, so let us consider the dimensions of the column is, let us consider here as 0.3 cross 0.3. So just we need to multiply this expected dimensions with each floor height in order to calculate the volume of the concrete. So let us consider here as 3. So just we have to multiply this expected value, 3 multiplied by 3, which is equals to 0.09 multiplied by 3. Let us consider approximately equal to some value of A, which is in meter cube section. Let us consider. So let us some otherwise we can consider the example. Let us take here as A meter cube is the value. So let us consider dimensions of the block, which is equals to 0.3 cross 0.3 is the column dimensions multiplied by each floor height. Why? Because the column section will be exist for each floor height. So basically if you take this value 0.3 cross 0.3 multiplied by 3, it will get the volume of, let us consider here as 0. Some example of 0.27 value. So here getting the 0.27 value. So let us consider this expected value is here as 0.27. So this is the volume of the concrete that is required in percentage for that respected member, which is related to 0.3 cross 0.3 cross 3. Okay, so basically it is 0.237 meter cube. Let us consider. So for casting this respected 0.27 meter cube for this, so just we need to consider the column minimum and maximum percentage. If you consider the maximum percentage is 6%, just initially we need to multiply this respected value of 0.27 with the 6%. Okay, so which is equals to 0.27 multiplied by 6 by 100. Okay, let us consider here. So just I am considering 6 by 100 multiplied by 0.27, which is get the value of 0.0162. So 0.0162 is the value that is required for the concrete member steel section. 0.0162. Let us consider. So this is the quantity that is required in meter cube for the steel section. So but we need to convert this respected meter cube into kgs. So to calculate the respected value from meter cube to kgs, just we need to consider the density of the steel section. Basically we have the density of the steel is approximately 7850 meter cubes, kg per meter cube section density. Okay, why? Because it is related to the mass by volume section. Okay, so just we need to multiply these two values, which is related to 7850 here. Let us consider here. Just I am taking 7850 multiplied by your respected volume of 0.0162 value. So just I am multiplying this respected value 7850. So it will get the value of approximately 127.17 kgs. Okay, so in the same process you can calculate the remaining value. So if you want to calculate the steel that is required for the respected slab, just you need to multiply this respected 0.7 or 1%. Let us consider 1% of the steel. 1 multiplied by your respected dimensions. Volume initially we need to calculate. So for that we need to multiply the length of the slab and width of the slab multiplied by your respected thickness, so that it can get the value of the volume. Okay, so just we need to multiply that respected volume with the value of your respected percentage, so that it can get the value of some so and so percentage. Just we need to multiply this respected percentage with the density of the steel section, which is equals to 7850 kg per meter cube, so that it can get the value of steel that is required for the respected member in kgs. Okay, so this is the simple concept which is related to the minimum and maximum percentage of the steel that is required for casting of any one of the building section. Okay, so which is having minimum percentage is 1.2 for the beam, 1.6 for the column, 0.7 and 1% for the slab, 0.7 and 0.8 for the foundation. Okay, so this is the complete process. If you have any queries about this respected minimum and maximum percentage of the steel in concrete member, please text me your questions in the below comment box. I will try to give the answer for that respected questions. Thank you.